All right, everyone, I've got a great lesson for you today. We are going to explore the ins and outs and nuts and bolts of how to find a great deal on a car using Python and some data science analytics. So I found this website just a couple of days ago. Let me show you this thing. It's kind of cool. I looked at a couple different car websites. This one looks pretty interesting and pretty straightforward because they expose a lot of the data on the landing page here. On some of the websites I looked at, you had to go ahead and click into the hyperlink to get more information about the car. Let me look at this. CARS. I think cars.com was one, right? Pretty obvious. Cars.com. You really can't mistake that for anything else. Let's look at electric. Oh, so here's a good example. So here's the landing page for the website, right? You have some cars over here, some cars over here, all new EVs. If I scroll down here, Volvo certified, you have the price and the mileage and the make of the car, but that's it. You don't have a whole lot of detail here. If you click on the link, you can get extra details like color, interior color, MPG, fuel type, VIN, mileage, extra features, entertaining, which is great, but I didn't want to do that much work. I'm a little bit lazy. I wanted most of the details of the car exposed in this page, so you can see that here. So you have 2023 Ford Edge, and I can't click on it. I can't select it for whatever reason. That's fine if I could, but whatever. Maybe I can do this. Okay, so you have 2023 Ford Edge. You have the price over here. Um, Below market, 5,456 below market miles, no accidents, four-cylinder, all-wheel drive backup camera. I just like this site because it's exposed here. I don't have to drill in. If I go to this site, I'm gonna have to click on all these links over here and then down here and then down here, and then I can get more details. So you could do that, and I have other videos I created. It's called Parent-Child Relationships. This is the child. If you go back here, this is the parent. So you have the upper level and lower level. You have to click into the lower level, go back to the parent level to go to the next car and do that over and over. You can totally do that. That's fine. Takes a while for it to run, and it takes a little bit more effort to set the code. I didn't want to do it, so I just created this version that's pretty simple and pretty straightforward. You can see all the data on this main landing page. Okay, so that was my motivation for that. So I'm not actually going to run the code. You can see down here, I ran it and I did my screen scraping. I got page 1, 2, 3, 4, 11 scraped. There was one issue over here. I looked into it. It's one record, and we have about 419 or 420 records here. So I missed one, and there was some little disconnect with the web. I'm on Wi-Fi now. Maybe it had a glitch or something. Who knows what happened? So we missed one record. It looks a little bit ugly, but it's just one. We have like 420 records that we can use, and that's enough for the analysis. Okay, so I'm not too concerned about one. When you run it, you can have everything perfectly scraped. If you get this message, don't worry about one record that's dropping out. It's no biggie. So what we're doing is going to this website, looking in this website. If I go over here and right click, and I'm not going to get too far into it today because this is not a lesson about screen scraping. But I do have several videos on how to do screen scraping. But I just wanted to take you through this just so you have like a basic understanding. So if you right click on this and go to inspect, you can see where the source comes from. It comes from this A class. If I put the mouse over it, that 2023 Ford Edge gets highlighted. And if you look closely in here, you can copy this, let's say outer HTML. If I put this into a text file, you can go over here and you'll see all the HTML rendering for that link. And if you look close, you'll see that right here. I think 2023. Yep, Ford Edge. So we would look for that tag in here, div tag, and this should have some class. Like if I stretch this out, what does the class say? Class looks like size 16, text gray, bold. So everything with that div class is associated with this detail about the car. 2023 Ford Edge, and if you go over here, 20,688, go to inspect. And why is it not taking me there? Now there should. Did I also get that from there? Oh, here it is. It's the next one. Okay. So if you go over here, expand that div class and this, there's the price right there. If you look real close, 2,688. See my mouse like kind of in the middle there? And you can go down here, see 5456 below market, great price. So that's how you get the HTML behind the behind the website, right? So I told Selenium, Selenium is an interactive web driver right here. Go ahead, um, navigate to this website right here, uh, extract that URL, and create a vehicle list right here. I'm going to append everything to vehicle list. So if I do Control F, vehicle list gets everything appended here. The dot append is the property that takes the price, year, make, model, mileage, engine, dealer location, features, and so on and so forth. So I'm parsing that by this. Heading 3 is the price. FW normal, size 12, that's the class name. So you have to look very carefully at these HTML elements. And once you find that, you know how to assign those HTML variables to that, right? I go over here and I can get the price. We just saw that. There's the price, 19,299, and this one has, what is it going? It has that 6,400 below market. Okay, so that's how you get everything. You assign it to these variables and take these variables and append it to the list and take the list and then convert that to a data frame down here. So we have a nice, neat, orderly data frame structured in a way that we can see all the rows and all the columns here, and everything is organized very neat and very clean. So we have nice, clean price, year, make, model, car details, price below market, and so on and so forth. These are the features here. Everything actually came in together, like all-wheel drive backup. That comes down here. All-wheel drive backup, Bluetooth, keyless entry, upgrade headlights. That is that. And I just told Python to go ahead and explode those features. I have df column name is features. The first data frame had features, and I said go ahead and explode that into features 1, 2, 3, 4, and I think 5. Yep, they have 5 features. So we're splitting that string on the comma delimitation. You can see very closely there's a comma delimited after the all-wheel drive. Four-wheel drive, this is a comma. So we split that and expand that to feature split, and we call this I plus 1 increment plus 1. So we get features into features 1 through 5. Okay, so we've got that done. That's pretty cool. I saved everything to a CSV on my desktop just because it does take a while to do the screen scraping. This could take 5-6 minutes, could take maybe 10 minutes if you have a slow connection. And if you make a mistake on the data frame, you'd have to go back and get it again. If you make another mistake, get it again. Make another mistake and get it yet again. Okay, so it takes 10 minutes to do the screen scraping. You probably just want to do it once, save it to your desktop. And if you make a mistake in the data frame, just reload it from your desktop. This will take a fraction of a second, maybe half a second, and you can continue. If you have to wait 10 minutes for this whole screen scraping job to finish off, you're really doing yourself a disservice because you're going to sit there and wait for something that you didn't have to wait for if you put it into a CSV on your desktop. Okay, so so we go ahead and clean this up a little bit. We have $sign here, and we have a comma over here. So machine learning algorithms and anything in the data science world, most things in the realm of computers don't like $signs, and they don't like commas and things like that. So we're just going to go ahead and do find and replace anything that has a $sign. We're going to replace a column. I'm sorry, a comma with nothing. Okay, that's it. So we're just cleaning up the data frame and then aggregating prices to get a grouped price based on year, make, and model. So if we have the year, make, and model all the same, we can consolidate that into one vehicle. Okay, we don't need 3 different vehicles because then we're creating duplicates. Now you can have slightly different features over here, and of course the mileage is going to be similar, but probably different for different vehicles produced in the same year that have the same make and the same model, and the prices are going to be slightly different, right? But you can take the mean of the price and the mean of the mileage and then consolidate these 3 columns over here. You see this all the time in the SQL world. You see it now in the Python Pandas data frame world. Okay, we just want to go ahead and create a mean price down here and then a mean mileage down here if these features are the same. So if year, make, and model are all the same, let's get an average for everything, and then we can compare this price and this mileage to the average of other cars that have the same year, make, and model. Okay, so that's what we're doing there. And I used kind of a little trick. Instead of merging two data frames together, I'm going to merge on the left. So if you do a left merge, you take everything on the left-hand side here and take only the matches on the right. If you do a right merge, you take everything on the right and match it with only the matches on the left. Inner merge takes everything it matches. Outer merge takes everything in the whole universe and then merges out together, right? So those are the ways to do that. For my purpose here, I think left is the most appropriate. Then we have our final data frame like this. So we started off with 420 records. One got dropped off. Remember, we had an issue over here with this guy. Where is that? Over here. Sorry. Yeah, if I go up here. So this thing didn't get scraped for whatever reason. I don't know what it is. We lost one record. So we have 419 out of 420. I'm not going to lose any sleep over that. That's one record that got dumped or got spit out or chucked out for whatever reason. But we still have a decent data set, 419. And honestly, like, more is better. If we had just over 400 cars here, if we had 4,000 or 40,000, 400,000, we could do a much more comprehensive analysis. It'd be more robust and more meaningful. We only have 400, basically because I don't want to sit here and wait all day for all of these screen scraping tasks to finish off. And this would take a long time. We have quite a few pages here. What does it go up to? Let me see. So if we go up to 6, it goes way beyond 6 because I got 20 pages. And keeps going and going. Oh, 126 out of 19,972. So now I'm curious. Now if you have 19,972, so you have 20 out of 19,272. So, okay, so how many pages do they actually have here? You would divide that by 20, 1920 divided by 20, like 20,000 cars, I think. And you have 20 on each page. Let's see this quick. Enter equal that divided by 20. Okay, this has some thing over here. Oh, it has a space at the end. Okay. Yeah, almost 10,000 pages. Okay, so I'm not going to screen scrape 10,000 pages. There's no way. And the system would probably shut me down if it saw that kind of activity. It would probably have some denial of service flag popping up or something. So I got the first 20 pages and it has 10,000. So we just got a small fraction. So what is that? Calculate. Let me see what this is. We got 20,000, 9,500 pages. Divided by 20 cars, right? Oh, that divided by, yeah, 20 per page. Yeah, 475. I'm not doing that, okay? I did 20 loops. I'm not doing 400 loops. So anyways, we have all of our data frame assembled nicely here. So we have price here, make, model, car details, price below market, vehicle history, engine type, vehicle location, and then the features over here. Then I created some feature engineering features over here. I ran a feature engineering exercise to create price mean, mileage mean, price deviation. That is the price minus the mean. Mileage deviation is the mileage minus the mean, and price rank. So now this gets pretty interesting, right? So we have price deviation, price minus price mean, mileage deviation, mileage minus mileage mean. So that's how we get these two. Price rank comes from here. This is the price deviation. We're assigning a ranking. Ascending equals true. So we're saying lower is cheaper. So lower cost price is cheaper car, and that's true, right? That's non-negotiable. Can't argue with that. Lower is cheaper mileage deviation. So we have a mileage rank. So we have a price rank, mileage rank. Lower is cheaper. Feature count. This is the number of features plus 1. So the feature count is 5 because we have 5 features. 1, 2, 3, 4, 5. Okay, comma separated. That's how we get the feature count. And final rank is price rank, mileage rank, and feature rank. And we're taking the average of these 3, right? So we're ranking feature count, ranking mileage deviation, ranking price deviation. So those 2 and feature rank. Wait, sorry. Feature count is a rank. Feature rank. Oh, here. That we're taking the mean of this and this and this and assigning a final rank to that. So that's how we're assigning a ranking to the cars. We're saying which car is better, which car is not quite as good, which is the worst car. I'm going to get to the top 10 best cars at the end of this. You'll see that in a couple of minutes. And we'll see the top 10 worst cars based on, again, these features. So mileage mean, oh, sorry, price deviation, mileage deviation, and then feature rank, right, to get the final rank. That's how we got that, right? So if you forget, just look at the code. It's all right here. It's all exposed. It's given to you right there. So we are grouping all the features here now and calculating price deviation. I think we did this, right? Oh, no, sorry. We did the price mean and the price and the mileage mean. So it's slightly different, okay? So price deviation here and mileage deviation before. I'm sorry, we did do that. We did that. Okay, so we don't have to repeat this again. We had two new features over here. The price mean grouped and the mileage mean grouped. Okay, we still have the same. This is rows and columns. 419 rows. We missed one because there was some weird glitch during the web scraping process. And we created two new columns over here. So 419 rows, 22 columns. These are the two new columns, price mean grouped, mileage mean grouped. So we can move on. We are going to group everything together and assign the order that this data frame is displayed in based on the rank. We want ascending equals true, rank ascending equals true, and rank ascending equals false for the feature count. Okay, so higher is better here. Lower is better. So feature count lower is better. And we're going to do everything or sort everything in ascending order by the final rank. Okay, so I hope you're sticking with me. It does get a little convoluted here, but don't worry about it. You'll have all this code. I'll share all the code with you when I share the video just a little bit later today. And I've got my notes in here too. Okay, so rank cars based on cheap or expensive, normalize the features for easy comparison, and then sort the final rank by cheapest to most expensive. So we're looking at value vehicles here. We're looking at cheaper cars with relatively lower miles and relatively lower price. This is going to get a higher ranking in our ranking order system hierarchy here, and more expensive cars are going to get a lower ranking. Okay, if you're Mark Zuckerberg or Jeff Bezos or Bill Gates, congratulations. Most people are not like that, so we're looking for value. We're looking for deals here. That's how we're assigning our ranking. Okay, so I'm going to go ahead and create a k-means clustering experiment here. I don't know what the actual number of ideal or optimal number of clusters is, so I'm going to loop through a range of 1 to 11 and let k-means algorithm tell me what the number is, the maximum number. You could say 4 or 5. It's where the elbow bends. If you bend your elbow where the curve bends, the most is probably the optimal number of clusters. It's really getting flat by 7, 8, 9, 10. That you really can't argue with. And it decreases quite a bit from the number of clusters starting at 1,200, right? There's no way we need 1,200 clusters. We get down to 6, or sorry, inertia is the sum of square distance. Number of clusters, 1, no, because we'll never have number 1 cluster, right? There's no point in doing clustering if you just have 1, 2, 3, 4, 5, 6, I think is optimal. That's what I use over here. So I said, give me a cluster of 6. Where's my 6 here? I think I said 6. What? I don't see a 6. Give me a second here, 6. Oh, yeah, okay. That's it. So, yeah, you don't see it over here. It's telling you to loop through 1 to 11, right? That's what we're doing. I'm saying it's 6. You could argue 5, maybe 4. I think 6 is okay. You can do 4 or 5. It doesn't really matter. I'm picking 6 here, and I'm saying give me 6 clusters based on car details, price, mileage, and assign a cluster. So assign a cluster to the data frame right here, and then displaying the results based on car details, price, mileage, and cluster, which we just created a new feature here called cluster. Then we're going to go ahead and create a scatter plot of all the clusters. So we have the F group, that's our data frame, price and mileage. It's going to be the X and Y. The color is going to be the cluster. That's normally how you do it. You can pick another color if you want. I think cluster makes the most sense. So you can see here, these are all 0 clusters. Go down here, you have cluster number 4. This is cluster number 1. You can see obviously the bubble pops out from the chart. This is cluster 2, and down here in yellow we have cluster 5. So everything that is assigned by proximity to its neighbors here is the same cluster, and everything that's homogeneous will go into the same cluster. Everything that's heterogeneous goes into different separate clusters, right? So I just zoomed in here. That's why I like these Plotly charts. You can mouse over, you have the animation here, you have the pop-ups. so on and so forth. So we have all our clusters. That looks nice. And we have a couple cars over here. This is a P400 SE four-wheel drive. Price is 104,000. Mileage is 12,000. You can see it's a lower mileage here. The prices tend to be more expensive. Although if you get to, you can buy some cheaper cars over here for under 20K, right? And the mileage is pretty low. Here we have 8,900 miles, 12,000 miles. Here the price really drops as you get more and more mileage. Here you have 157 miles, 150 miles, 150,000 miles. This is for a cargo van, another cargo van, low roof cargo vans. Cargo vans are pretty popular, I guess. Here's a LX four-wheel drive SUV. Price, oh, here's a GT Quattro sedan. Price is 10,000, mileage 74,000. So everything is working like it should with the clustering, with the pricing, the mean price, mean number of miles. But actually, what is the best car here? We still haven't answered that question, right? So we're going to try to derive that in just a minute. We have, again, the car details. That's important. Price, mileage, P-score, and mileage score. So now we're looking at extreme examples. Anything that has a Z-score greater than 3, absolute value of 3, so greater or less than -3, right? And greater than +3 or less than -3, absolute value. Anything is greater. This is going to be an outlier, okay? So we're going to have price Z-score and mileage Z-score. So these have higher mileage, right, for the category and higher prices for the category. That's how they're getting these high Z-scores, right? These are outliers. So we'll use that in our final analysis to determine what are the top 10 best cars and top 10 worst cars. Now we have, again, the price and the mileage scatter plot. So over here, you can see the type of car again. You can see all the car details, the Z-scores. So before we had just, remember in this plot, the price and mileage, right? Everything is plotted out there, and you have the color bar plot on the right. That's called the legend. The color ranges over here on the right is the legend, and over here again you have a similar legend. Here you have one car. The price is 104,995, and this is an outlier for both the price and the mileage, right? So that one gets kicked into the Z-score bucket over here. So the final thing we need to do is take the price Z-score, right, and look at the minimum, look at the maximum, divide the min by the max, right? And we're doing this a few different times by the mileage, price deviation, feature count, feature rank, to try to get the top 10 recommended cars and all of the cars. Remember, we had 419 cars. Of the 419, these are the top 10 recommended, and these are the reasons why. You have the car details: sedan, four-door hatchback, Model Leaf. Price is 11,000, so relatively cheap compared to the others in the group. This is 15,000, this is 21,000, 19,000, so pretty cheap. Pretty low mileage, only 12,000. This guy has 13,000. The scores are very similar. This is just probably slightly more because this has slightly less mileage. Otherwise, these cars are almost identical, right? This one just has like 400 miles, 400 miles more. This has 400 miles less, right? The price mean is the same as it should be, and the mean mileage mean is the same. Price deviation is basically nothing, and the mileage deviation is 194. Okay, so these are the top 10 cars, okay, and the whole universe of cars that we looked at, these are the top 10, and we can sort the final score in ascending order, okay, with this Range Rover. Oh, and yeah, top 10, I lost track for a second there. This is the top 10 recommendations as being the best cars, right? And you can see why. Pretty affordable, 19K, low mileage, 15K, not too bad, pretty low mileage, 20K, that's probably the highest one, but again, low mileage, 5,300 miles. These are the worst cars based on these metrics: price, mileage, score. Okay, so this is 104,000. I don't have over 100,000 sitting around my bank account, so this is off the table for me, probably for most of the people here. 95K, 9,500, but this has a lot of miles, 157,000 miles. This is relatively affordable, 11.6, but high mileage, 68,000. It's a lot. Now high mileage, but 37,000, almost 40, getting up there, right? 12,300, lots of mileage, lots of mileage, lots of mileage, lots of mileage, right? So these prices a little bit lower, but the miles are up there, right? Like, is this thing going to last too much longer? Who knows? Might be near the end of its life, but these are the 10 worst. Okay, worst 10, and these are the top 10. You could call this the best 10, top 10, whatever you want. So in summary, I think I had one more chart. Yes, this is the top 10. That's what I'm looking to plot here. If you want the bottom 10, you could certainly get that. This would probably be one of the cars recommended. About 11,000 for the car. Mileage is about just about the same. About 11,000 mileage, 11,000 price. No, 13,000 mileage, 11,000 price. Here the mileage is 8,000. Price is 13K. Over here you see the price of mileage, price of mileage, price of mileage. Here, preload miles 2,300, and the price is 22,000, basically 21,000, right? You can round up by $1, $22,000, 22,000. Sorry. So that's it. So that's how to find the best cars and the worst cars in a data set of cars using a few techniques: average price, average mileage, ranking, methodologies, and everything coalesces or arrives in some type of confluence arrangement in the final analysis here in the final data frame. So that's it, how to find the best cars and the worst cars. If you're into that kind of thing too, I just show the worst just to be comprehensive there. Really, you probably can ignore this. You should really focus on the top 10 best cars, which is right here. So that's it, guys. Hopefully that was informative and enlightening and useful to you. I learned a little bit putting this stuff together, but I knew most of this stuff, so it's pretty straightforward for me. So I just wanted to share that knowledge with you, drop some nuggets of wisdom. Hopefully that helps with your learning experience as you, um, complete your journey through learning Python and data science and machine learning and all that good stuff. Okay, so I'm going to wrap it up. Thanks for your time. Enjoy the rest of your day. Bye.